Hi dear student, welcome to my channel Education Shop. In this video, example 11.3 from the book Heat and Mass Round by A.Çengel, 6th edition. Here is the statement of the example 11.3 from the chapter of heat exchanger. Steam in the condenser of a power plant to be condensed at temperatures of 30 centigrade with cooling water from a nearby lake which enters the tubes of the condenser at 14 centigrade and leaves at 22 centigrade. The surface area of the tube is 45 meter square and the overall heat transfer coefficient is 2100 watt per meter square dot Kelvin. Determine the mass flow rate of the cooling water needed and the rate of condensation of the steam in the condenser. This is the condenser. This is a schematic diagram of the condenser that is described in this statement. The steam enters at 30 centigrade in the condenser and interact with this cooling water pipe. The steam release energy and at the bottom the condensate will collect at the temperatures of 30 centigrade. The cooling water inside temperature is 14 centigrade. The cooling water outside temperature is 22 centigrade as it absorbs heat from the steam and it becomes condensed. The TC out, cool temperature of the cooled fluid, outlet temperature of the cooled fluid, that is 22 centigrade, and the hot fluid inside temperature is 30 centigrade and the hot fluid outside temperature is also 30 centigrade. Now let me write the data that is provided in the statement. The temperature of the hot fluid in, that is 30 centigrade. The temperature of the hot fluid out is also 30 centigrade. The temperature of the cooled fluid in is 14 centigrade and temperature of the cooled fluid out is 22 centigrade. The surface area of this tube is also given, that is 45 meters square. The overall heat transfer coefficient is U and is 2100 watt per meter square dot Kelvin. Required data: mass flow rate of the water, mass flow rate of the cooled water flowing in the tube, and the mass flow rate of the steam that is condensed. This is we need to find. Let's come toward its solution. Delta T1 is equal to the hot temperature in minus cool temperature out. Hot temperature in is 30 centigrade and cool temperature out is 22 centigrade. Just simply subtract and you will get 8 centigrade. Then delta 2 is equal to the hot temperature out minus the cool temperature in, and that is equal to 30 minus 14 and you will get 16 centigrade. Then the log mean temperature difference is equal to delta T1 minus delta T2 ln delta T1 divided by delta T2. What is delta T1 value? That is 8 minus delta T2 16 divided by ln 8 divided by 16. Solve this on calculators and you will get the log mean temperature difference value, that is almost 11.5 centigrade. Now the amount of heat transfer in the condenser is equal to the overall heat transfer coefficient, surface area, times the log mean temperature difference. Overall heat transfer coefficient is 2100, surface area is 45 and log mean temperature difference is 11.5. So after multiplications on calculators you will get the rate of heat transfer value, that is 1087 multiplied 10 to the power 3 watt, and this 10 to the power 3 is basically equal to kilo, so I can say that 1087 kilowatt. We also know that Q dot is equal to m dot mass flow rate of the cooling water, Cp of the water, and its corresponding change in temperatures, that is T cooled out minus T cooled in. Put the value and we will rearrange this equation for m dot W, that is the amount of water flowing, cool water flowing in this tube. I am rearranging equation for m dot W, so I can say that m dot W is equal to, this side is Q dot, divide both sides by Cp into this change in cool water temperatures. We will get here the Cp and change in temperature T cooled out and T cooled in. What is Q dot? That is 1087 multiplied 10 to the power 3. Cp value for water is constant, that is 4.187 into change in temperature, this is 22 minus 14. This simply solves and you will get the mass flow rate of the cooled water, and that is 32.5 kg per second. Next we need to find the mass flow rate of the steam, that is equal to Q dot mass flow rate of steam and the corresponding enthalpy of vaporizations of this steam temperature. And the temperature of the steam was given, that is 30 centigrade. At this 30 centigrade you can see the enthalpy of vaporizations from the steam table, that is 2431 kilojoule per kg. The HFG value is 2431 kilojoule per kg and the Q dot value we calculated previously, that is 1087 kilowatt. And I can say that mass flow rate of steam is equal to amount of rate of heat transfer divided by enthalpy of vaporization at 30 centigrade. Its value is 1087 multiplied 10 to the power 3, whereby HFG value is 2431, and this K means 10 to the power 3. This will cancel out with this. Solve this on calculators. You will get the mass flow rate of the steam, and it is 0.45 kg per second, and is our final answer. I hope you understand.